This lesson is on the dangers of ionizing radiation. So as you can see here, we have a poster indicating the various sources of ionizing radiation, what different exposure levels will do to you, and the various forms of illness that will result from those exposures. If you'd like to look at this in more depth, pause the video. The title for today's lesson is The Dangers of Ionizing Radiation. Before we start this lesson, you should be able to describe the mass and charge of an alpha particle, beta minus particle, and gamma ray, and you should be able to state what happens to a neutral atom when alpha particles, beta minus particles, or gamma rays collide with it. Pause the video now to attempt these questions. So, the relative atomic mass of an alpha particle is 4 because it has 4 nucleons inside it. That's 2 protons and 2 neutrons. Its relative charge is +2 because it has 2 protons inside it. Meanwhile, the beta minus particle has a relative atomic mass of effectively 0, but it's actually 1/2000th that of a proton, and its charge is -1, so it has the opposite charge to a single proton. And gamma rays have a mass of 0 and a charge of 0. Now, when an alpha particle collides with a neutral atom, it can take 2 electrons away, ionizing that atom. When a beta minus particle collides with an atom, it can knock an electron out of the orbital, ionizing that atom. And gamma rays can be absorbed by electrons. That gives the electrons enough energy to escape the atom, turning that atom into an ion. This is why we call it ionizing radiation. When comparing the danger of alpha particles, beta minus particles, and gamma rays, there are 2 important factors: the relative ionizing potential and how deep that radiation could go into a material. This is known as the penetration depth. So ionizing potential, this is due to both how much an atom can be ionized by each radiation and how likely it is to be ionized. See the previous lesson on ionizing radiation for more information on this. Penetration depth is how deep into a material something can travel. So, as an analogy, a metal drill can penetrate several centimeters of steel, but cannot penetrate into diamond. So it has a different penetration depth depending on the material. Alpha particles are the least penetrating and can only pass around 15 centimeters through air. And also they are blocked by thin sheets of paper. The thicker the paper, the less alpha particles will get through. Beta minus particles are more penetrating as they can pass through around 1 meter of air. They can pass through paper, but they are blocked by sheets of metal around 5 millimeters thick. Again, the thicker the sheet, the more will be blocked. And gamma rays. They are the most penetrating as they can pass through paper and sheets of metal, but they are blocked if you have several centimeters thick of lead. Now, gamma rays can also pass unaffected through the air. Effectively, gamma rays have an infinite range through the air. Answer the questions shown on the screen using the sentence starters provided. Pause the video now to take time to do that. So now we need to consider the relative danger of all three, the alpha, the beta, and the gamma. So, since alpha has a small penetration depth, it makes them less dangerous than beta minus emitters when outside the body. This is because alpha particles can't really penetrate very deep into the skin. However, because they are so strongly ionizing, if they're ingested, that means taken into the body, they are the most dangerous, as they can get into the bloodstream and then destroy the cells in the walls of the capillaries and cause severe internal bleeding. So figure B shows Alexander Litvinenko before and after ingesting an alpha emitter. Unfortunately, he died soon after. So Alexander Litvinenko was poisoned with polonium, which has an atomic number of 84. This was an unstable version of polonium. It was an unstable isotope, and so it was emitting alpha particles as it decayed. That polonium would have ended up in his bloodstream, and then as it was in his bloodstream, it would have emitted alpha particles, damaging the cells in the capillaries. So alpha particles are extremely dangerous when an alpha emitter has been ingested. Beta particles have a larger penetration depth than alpha particles. This makes them far more dangerous outside the body because they can penetrate deep into the skin. In fact, they can pretty much get all the way down to the bone. They are also made much more dangerous if they are ingested, but they're still less dangerous than alpha emitters when they're ingested. So figure C shows a worker at Chernobyl whose gloved hand was exposed to very intense beta radiation. As you can see, the glove did very little to protect him. The beta particles were able to pass straight through the glove because of their penetration depth and ionize the skin on his hand. Finally, gamma. The fact that gamma rays pass through most materials without ionizing them actually makes them the least dangerous, because even though they can penetrate deep into the human body, they come out mostly from the other side without having ionized an atom. So they pass straight through you in most cases without affecting you. Of course, very intense gamma radiation, so a very, very large number of gamma rays passing through you, some of them will, of course, ionize molecules and atoms inside your body. This is, in fact, a method they use to treat certain cancers. Answer the questions written on screen using the sentence starters provided. Pause the video now to take time to complete this. Now, a further danger is caused when ionizing radiation collides specifically with atoms in a molecule of DNA. Now, cells are able to repair DNA, but they don't do it perfectly. Sometimes they make a mistake when they repair the DNA, and we call this mistake a mutation. Now, in some rare instances, these mutations cause the cell to replicate uncontrollably. This uncontrollable replication of cells is often referred to as cancer. So in this particular case, to get the marks in the exam, you need to be saying ionizing radiation, that's 1 mark, can break the DNA to cause a mutation, that's 2 marks. This can lead to cancer, and that's 3 marks. Now, figure E shows a woman who developed thyroid cancer due to ingesting small doses of radium on a daily basis. Now, radium is an alpha emitter. She was employed at to paint fluorescent clock faces with radium. She would lick the paintbrush to wet it before painting. Now, radium was used because when radium emits alpha particles, if those alpha particles happen to collide with a fluorescent material, that material will fluoresce. So it made these lovely watch faces that would glow in the dark for a very long time. In fact, you can still get hold of some of these. They're not illegal, and they're not that dangerous themselves. They were only really a danger to the people who were painting them in the first place. The people who were regularly exposed to that radium and who, as I said, would lick the paintbrushes in order to wet them. Answer the question on screen using the sentence starter provided. Finally, here you can see the textbook page. If you'd like to complete more activities, you can read through this yourself and complete the questions. These are the same questions that we've done before, but with a couple of problem solving and revision questions. But let's quickly look at the problem solving questions before we finish. Compare and contrast the relative danger of alpha, beta, and gamma emitters, both inside and outside the body. This kind of question may end up being a 6-mark question in your exam. Suggest how you might protect yourself from each of these 3 types of radiation. So looking at the penetration depth with the different materials, consider how they might be blocked from getting into a human.